Storage Note 26. 7. Machine Safety Deck 03. Objectives 1. 2. Help participants understand principles of machine safety. 3. To provide ways of machine safeguarding. 4. To understand the importance of LOTA. 5. Recognize the important elements of an effective machine safety program. Machine safety. It is the prevention of accidents when working with machines. Machines are a source of severe accidents which can result in crushed hands and arms, severed fingers, blindness, death. Safeguarding any machine part that may cause injury. Importance of machine safety. Prevents severe accidents, loss of life or serious injury, loss of production/cost of machine downtime, equipment damage and repairs. Possible litigation. Having time spent on accident investigation and other statutory requirements. Causes of machine-related accidents. 1. An individual making unwanted contact with a moving part of a machine. 2. Something flying from the machine. 3. A machine malfunction, including mechanical and electrical energy sources failure. 4. Workpiece movement during a forming or cutting process. 5. Unguarded or exposed moving parts such as power transmitting devices. Effects of machine-related accidents. Can result to severe injuries. Loss of trained and skilled employee. Loss in productivity. Damaged equipment. Ask AI. Alt. What is a machine? An assemblage of parts that transmit forces, motion, and energy in a predetermined manner. Can be simple or compound. Ask AI. Alt. Where mechanical hazards occur. Ask AI. Alt. Other moving parts. All parts of the machine which move while the machine is working. Point of operation. The point of operation, that point where work is performed on the material, such as cutting, shaping, boring, or forming. Power transmission, apparatus. All components of the mechanical system that transmit energy to the part of the machine performing the work. These components include flywheels, pulleys, belts, connecting rods, couplings, cams, spindles, chains, sprockets, cranks, and gears. Alt. Hazardous mechanical motions. Rotating. Turning around on an axis or center. Alt. Reciprocating. The back and forth movements of a machine part. Alt. Traversing. Continuous straight line motion of a machine element in either direction. Alt. Cutting. May involve rotating, reciprocating, or transverse motions such as milling and lathe machines. Alt. Punching. The danger of this type of action occurs at the point of operation where stock is inserted, held, and withdrawn by hand. Ask AI. Alt. Shearing. Involves applying power to a slide or knife in order to trim or shear metal or other materials. Alt. Bending. Bending action results when power is applied to a slide in order to draw stamp metal or materials. Alt. Hazards associated with rotating motions. Rotating coupling with projecting bolt. Alt. Rotating shaft and pulley with projecting key and set screw. Alt. Rotating pulley with spokes and projection burr. Alt. Cutting hazards from rotating parts. Caught by. Flying particles. Sparks. Alt. 3 types of in-running nip points. Parallel axes. Parts can rotate in opposite directions while their axes are parallel to each other. Alt. Tangential. Nip points are also created between rotating and tangentially moving parts such as belt and pulley and chains and sprocket. Ask AI. Alt. Rotating and fixed part. Such as screw conveyor, flywheels, abrasive, grinding, wheel. Alt. Pinch point/nip point hazards, examples. Rotating parts in opposite direction. Ask AI. Alt. Between rotating part and tangentially moving part. Alt. Between a rotating part and fixed parts. Alt. Machine guards. Guards are barriers that prevent entry of an individual's hands or other body parts into a hazard area. Installed to minimize the risk of injury to machine operators or other persons from hazardous machine parts, materials being processed, or scrap. Requirements for machine guards. Prevent employee contact with hazardous moving parts. Secured and durable. Prevent falling materials into moving parts. Create no new hazards. Must not interfere with worker productivity. Should allow for proper and safe maintenance and lubrication. Alt. Category of machine guards. Preventing access. Fixed enclosing guards. This type of guard is attached to a fixed surface and encloses the hazard. When in place, it prevents anyone from going over, around, under or through it to the hazard. The principal advantage of the fixed enclosing guard is that it always prevents access to the hazard area. Alt. Movable guards with interlocking switches. Prevents machine motion until the guard is moved into place. The interlocking method may be mechanical, electrical, pneumatic, or a combination of these. To be effective, interlocking guards must 1. Enclose the point of operation before the machine can be operated. 2. Keep the point of operation enclosed before the hazardous part of the machine motion ceases. 3. Prevent operation of the machine if the interlock fails. Alt. Two-hand controls. Two-hand controls are operator controls that require an operator to hold both controls down during the hazardous portion of the machine's stroke. ASCII. Alt. Adjustable guards. Manually adjustable. This type of guard can be positioned to accommodate a variety of operations or work, and when properly adjusted provides adequate protection from the hazard at the point of operation. Adjustment of the guard should only be performed during setup. Alt. Self-adjusting. Provides a barrier which moves according to the size of the stock entering the danger area. Alt. Preventing dangerous motion. Safety device. Any mechanical or electrical devices designed to protect a worker's hands or other body parts from coming into contact with the hazardous motion of a machine. Presence sensing device. A safety device which is designed, constructed, and arranged to create a sensing field, area, or plane that will detect in its field the presence of an opaque object. Photoelectric light curtain/presence sensing device. These devices emit a curtain of harmless infrared light beams in front of the hazard area. When any of the beams are blocked, the light curtain control circuit sends a stop signal to the guarded machine. Alt. ASCII. Alt. Pullback devices. Hold-out and restraint devices are cable and wristlet systems that attach to an operator's hands and to the machine's moving slide or ram, or to a fixed object away from the point of operation. They are usually used on machines having reciprocating motions. ASCII. Alt. Restraint device. Uses cables or straps attached to the operator's hands and a fixed point. Must be adjusted to let the operator's hands travel within a predetermined safe area. ASCII. Alt. Pressure-sensitive safety mats. ASCII. Alt. Pressure-sensitive edges. Alt. Emergency stops. Emergency stop buttons. Alt. Grab wire switches. Alt. Telescopic trip switches. Alt. Protective shields. Provides some protection from flying particles, splashing cutting oils or coolants. ASCII. Alt. Holder, jigs, push sticks. ASCII. Alt. The hierarchy of control measures. Engineering control. Fixed enclosing guards. Movable, interlocked, guards or protection devices. Protection appliances/other safety devices. Administrative controls. Provision of information, procedure, instruction, training and supervision. Signs. Alt. Personal protective equipment. Control of all energy sources through lockout/tagout system. Main cause of maintenance injuries fatal 5. Failure to stop equipment. Failure to disconnect from power source. Failure to dissipate, bleed, neutralize, residual energy. Accidental restarting of equipment. Failure to clear work areas before restarting. Alt. Sources of hazardous energy. Electrical. The uncontrolled current and voltage in electrical circuits. Alt. Mechanical. Exposed crushing or cutting parts of equipment or loose parts. Alt. Thermal. Such as steam or due to chemical reaction. Alt. Potential. Stored energy that may be due to gravity, hydraulics, pneumatics, vacuum or springs. Alt. Isolation of hazardous energy. Basic concept. Each person who could be exposed to unexpected energization or startup of equipment, or release of stored energy will utilize an isolation device which is under personal control. Alt. Lockout/tagout system, LOTA. The standard for the control of hazardous energy sources which covers maintenance of machines in which the unexpected startup of machines or release of stored energy could cause injury to employees. ASCII. Alt. Lockout devices. Lockout device. Device that utilizes a positive means such as a lock either key or combination type, to hold an energy isolating device in the safe position and prevents the energizing of an equipment. Included are blank flanges. Alt. Types of lockout devices. Plug locks. Ball valve lockout. Gate valve lockout. Group lockout HASP. Electrical. Blanks, hydraulic, pneumatic, and other pressurized systems. ASCII. Alt. Tag-out devices. A warning device, such as a tag and a means of attachment, can be securely fastened to an energy isolating device in accordance with an established procedure to indicate that the energy isolating device and the equipment being controlled cannot be operated until the tag is removed. Alt. Who are involved in LOTA procedure. Authorized employee. An employee who locks or tags machines or equipment to perform maintenance or servicing. Affected employee. An employee whose job requires him/her to operate or work in an area where servicing is being performed under lockout/tagout. Typical minimal LOTA procedure. 1. Notify. Notify all affected employees that servicing or maintenance is required on an equipment and that it must be shut down and locked out. Alt. 2. Identify. The authorized employee shall identify the type, sources and magnitude of the energy that the equipment utilizes, shall understand the hazards of the energy, and shall know the methods to control the energy. Alt. 3. Shutdown. If the equipment is operating, shut it down by the normal stopping procedure, depress the stop button, open switch, close valve, etc. 4. Isolate. Deactivate the energy isolating device, S, so that the equipment is isolated from the energy source, S. 5. Lockout. Lock out the energy isolating device, S, with assigned individual lock, S. Place a tagout. Typical. 6. Verify. Stored or residual energy, such as that in capacitors, springs, elevated machine members, rotating flywheels, hydraulic systems, and air, gas, steam, or water pressure, etc., must be dissipated or restrained. Verify the isolation of the equipment by operating the push button or other normal operating control, S, or by testing to make certain the equipment will not operate. Alt. Application of the lockout. For multiple energy sources, apply one padlock for each safety disconnect device. One padlock per person per equipment. No one is authorized to remove another's padlock while the person who owns the padlock is on site. Alt. Machine Safety Program. An effective machine safety program must have the following. Equipment/machine inspection and maintenance program. Installation of safety devices, guards, relief valves, provision for LOTA, interlocks, limit switches, etc. Compliance to regulatory requirements and standards, e.g. mechanical permits, OSHS, etc. Implementation of LOTA system. Having a machine operation and safety procedures. Machine alarm and warning signal system. Equipment/machine safety signages. Application of job hazard analysis. Summary. Machine safety is preventing access to dangerous motions or preventing dangerous motions to access. Machine safeguarding is generally accomplished by the use of machine guards and safety devices. The lockout/tagout system is an effective safety program when performing maintenance activity. Conclusion. 0% energy, 100% safety. A twist of the key could keep you accident-free. Play it safe from head to toe, off for fixing, on for go. A machine will bite with all its might. So put a lock on its appetite.